Hi folks, Davkus here, and welcome back to Davkus Builds. So in the last episode, we wired up our test circuit that we're going to be using in order to see what sort of signals we can get from the receiver onto the Arduino. But, as you probably noticed, I made a few mistakes in the last episode. So the first thing we need to do is fix those mistakes. Okay, so I've made a few changes to this circuit since the last episode. The first thing I did is on the receiver, I put the data lines on the correct pin. Initially I had them all the way over here on the left, but that's actually for the negative for the power. Normally you would be powering servos with this, and so these pins would be used to take power from these lines here and take them out to servos. In this case, we don't have any, so there's not supposed to be anything on here. The signal should be on this far right pin. On the Arduino board itself, I accidentally had these pins shifted one pin to the left, and so I had all of my signal lines all the way over here. So I moved it over here because I actually anticipated using this pin instead of this one. Same goes for over here. I actually had these in the 3 volt and 5 volt rather than the 5 volt and ground. On top of all of that, you'll probably notice that the colored lines here are a little different. I got rid of these circular ended wires because they were hard to fit in these small spaces. And I replaced them with some square ones so that they could actually fit next to each other quite nicely. Alright, now that we've got that fixed, before we move on to the code, I wanted to talk about pulse width modulation. The Arduino is not able to output a true analog signal. It can only do a digital signal, either a low of 0 volts or a high of, in this case, 5 volts. So in order to get a simulated analog signal, we need to use pulse width modulation. We can achieve this by varying the amount of time in a particular cycle between high and low that the signal is high. So if your pulse is, let's say, 10 seconds, if it's on all of the time, the entire 10 seconds, you have a 5 volt signal, and that's your standard digital signal. However, if during that 10-second interval you have 5 seconds of 5 volts and then another 5 seconds of 0 volts, the average between them becomes half of that, or 2.5 volts. Now, in our case, that time frame is going to be significantly smaller, on the order of thousands of times a second. And so we can actually simulate this analog signal by varying how much time that high signal is versus the low over time. And so we can continually change that amount of time, what's known as the duty cycle, which is the percentage of time that the signal is high versus the entire polling period. We can constantly modify that and actually get something that looks like an analog output signal. So that's what we're going to do with the LEDs in this particular case. In order to test our test circuit, we're going to use pulse width modulation in order to just fade up and down those LEDs on each color. So with that, let's take a look at what the code is going to look like.
All right, so what we're looking at here is the Arduino IDE, or Integrated Development Environment. This environment is built specifically for writing code in Arduino. Now this uses a C++ code language, but it's a bit of a watered down version in that a lot of the extra overhead that you normally have to do when programming in C++ has been stripped out. So when using the Arduino IDE, you only need 2 things. You need 2 methods, the setup method and the loop method. And when you first start a new program in here, those are given to you. Now the setup method will run at startup, and all of this code is only run once. And then the loop method is what runs continuously after the setup has been completed. Now, I will be putting all of the code that I look at throughout this series on my GitHub page. So if you want to take a closer look at it, maybe use it to test yourself, you can find it on my GitHub page and take a look at it for yourself. Now this program in particular is what we're going to be using to test our circuit to make sure that the LEDs are working as expected. To start, what we're going to do is actually assign these variables to the respective pin numbers for each of these colored pins for the LEDs. This way, instead of trying to reference the pins directly as the numeric value, I can just use this LED red in place of it, which is a little easier to read. I also have this variable fade speed, which controls how fast the LED fades from 0 to maximum. By decreasing this, it will actually speed up how quickly that fade happens. My setup method has two specific functions that it's going to do once the Arduino starts up. The first is to initialize serial communication back to my PC. This way I can send messages from the Arduino back to my computer and read them on the serial monitor, which I will show you in a few minutes. In addition to that, I'm also setting the digital pin direction, so input versus output, on each of the LED pins. Now, since we're not getting any information back from the LEDs onto the Arduino, all of these are going to be set as output. Now, the loop here is what's going to be continuously running after the setup completes. So the first thing that we're going to do in here is we're going to do another loop that's going to increment this I variable from 0 to 255. And we're going to use this as the pulse width modulated value to send out to the LED to determine its current brightness. But the first thing I'm going to do is send some serial messages back to my PC so I can see what's happening on the Arduino at this moment in time. And then I'm going to use this analog write method to specify which pin, in this case the LED red, which we set earlier as pin 3. And I'm going to then send out whatever the current value is for I in this inside loop here. Then after that, I'm going to do a short delay, and this is what controls how fast this fade runs. So by decreasing this delay, that means that it's going to spend less time in between each iteration of this inner for loop, which means those values are going to be incrementing faster, which means the fading is going to happen faster. And then after I'm done with this loop, we get from 0 all the way to 255. We jump out of that, and then I reset the brightness by doing another analog write of a value of 0 to turn off that pin entirely. And then we move on to the next color pin. So now that we have all of that straightened out, let's upload this and see how it goes. And there we go. Now we see the LED fades in from 0 to maximum brightness and then changes to the next color in line. And then once it goes through all 3 colors, then it will jump to the next LED in line, just like that. Now you can probably tell based on the colors shown in the serial display on the left that I have incorrectly wired the colors here. And so the colors don't match what the Arduino program shows. This is easily fixed by either changing the pin assignments within the Arduino program or just simply rewiring which output goes to which pin on the LED.
And there we go. Now we know that our test circuit works and the LEDs are able to fade on and off. So next, in the next episode, we're going to be turning on the receiver and see what kind of data we can get from the transmitter. With that, thank you very much for watching. If you like this video, please leave me a like. If you want to see where all of this is going, go ahead and hit that subscribe button. That's it for this episode. I will see you next time.